Okay, this lesson we'll talk about the iterable class structure. Okay, in Python, a class can be processed with the for or while loop using iterable class structure. But what is that? In the iterable class structure, we have two overload. Iter. This is an overload giving the iterator object. It's just like the C++ structure. Or we have the next. Okay? Giving new value at each column. Okay? At the end of the list of this iterable class structure, dictionary or str object next throws stop iteration exception to represent the end. Okay, but what is that in the real meaning or in the applications? Let's create an example. First of all, class sample can be built with the unit coefficients of these terms, and also we can give the star x. Okay, and so self arguments can be assigned with the arguments. Okay, we can give the multiple parameters. And so what about the iter constructor? And so self can be given here, and so the print iter func is used in here, and so self index can be initialized with a 0. Okay, and so the return self and that. How about this one, the next self? And so we can write the warning, the next func, which is in here, and so self index plus equal 1. Okay, and so if self index is greater than len of self arguments, and so raise stop iteration. Okay, but if this is not the case, return self arguments self index minus 1, because if we have the index with the 0 in this, but in the second place the first element is assigned to the 1, but in the Python the first in this is equal to the 0, and so we need to remove or the subtract with the 1 minus 1. Okay, and so as sample can be built with the 10, 20 and 30. Okay, if I run this code, and so we don't have any error in here. But what about this? L list s. Okay, and so if I rerun this code, see that first of all the iter function is called in here because it's a list. It's an iterable object, and so we can specialize by using this specific operator overloading. And after that, this s is assigned with the what? With the next index in here, because we have the 10, 20 and 30 values in here. And also we can print the what? Total list. Just like this one. 10, 20 and 30. Okay? And so if this is the case, the construction of list creating list is called the iter func, but assignments is done with the next in here. Okay, and so we can overload our specific class in order to what? In order to gain this property. in the applications. Okay. And so what about this one? The class my simple range function. You know range. This is a built-in function. And so we can create a stop in here, and self stop is equals to the what is stop. Okay. And so def iter can be built with the self, and so the print iter func can be called in here, and so self count is equalized with the 0. Okay. And so return self should be given in here because it's the iterable object, or it's the address values of the what the R instance. Okay. And after that we need to build the next operation in here, self, and print next func, and so the self count plus equals 1, and so if self count, if self stop, and so raise stop iteration. Okay. And also we need to return to the self count minus 1. Okay. This is the range. Just see that in this case we return to the count value, not the self argument one. Okay. So what about this one? R is equals to the what? My simple range with the 10. Okay. So first of all, if we run this code, and so we don't have any error in here, but L equals to the least R. Okay. And so if I run this code, see iter is 1 times called, and another one 10 times called the next function in here. Okay. And so what about this? If we print the L value in here, see 0, 1, 2, 3, 4, 5 up to 9 values is given in here. But for I in my simple branch function can be called in here, and so we can print the what, the I, and empty space, and also we can give the print. See, 0 next function, 1 next function, 2 next function, 3 next function, because at each case this next function is called right now, because this is the initialization values of the what, the iter function in here. This is the what, this is the creation, and after that at each case we call to the what, the next function, just like this one. Okay. Do you understand right now? Any problem or any question about it? In the second place, we can specialize the R class with the what, the self stop, and self stop is assigned with the stop. Okay. And def iter self, and it is returned to the what, the my simple range iterator with the self stop. And so what it reminds you, as you know, in the C++ we have the iterable class. For example, if you want to build the vector or the map in the C++, we can use the some basic built-in iterator class. And so this iterator class is a base class for the what, for the drive to what, the built-in vector class. And so if we have the my simple branch, we can generalize this solution just like this one, class my simple range iterator, and so def init self and stop, and we build with this one, and so self stop, and self count is assigned 0, and also def next self, and also if self count is equals to the self stop, and so raise stop iteration. Okay, self count was equal 1, and also return self count minus 1. Okay, this is the another implementation of the simple range iterator. This is the basis for whole the class, but this class is a specialized class. Okay, are my simple range called to the 10, and also we can give the what to print initial function in here. My simple range iterator, and also this is the my simple range. Okay, we can warn the user L equals to the list R, and so the print L. Okay, see, first of all, my simple branch is built, but in the second case, def iter called with the what? With the list assignment. Iter is called at this place. Then after that, we can run to the what? The 2, 3, 4, 5, 6, blah, blah, blah. Okay? But in the 10, just see that. This is the self count 0. And so this stop is assigned to the 10, but we don't have any one parameter in here because the self count is increased in here. I'm sorry. 0 to 9. Okay, we have a syntax error in here, semantic error in here. Okay, and also for I in my simple range with the 10, and after that the print I and also the print this one. See? This is the basis for the what? For our iterator class utilization in the Python programming language. And so we can drive the what? Some basis class to what? To utilize these properties for every generations. Okay? And so we can just use another example. Just like this one. We can create the Fibonacci generator. What is the Fibonacci? Can anyone say that? What is Fibonacci? Limit Fibonacci numbers. Current 0 and self next value. Can anyone say that? What is Fibonacci numbers? Yes. Thank you. Each of the number are the summation of the before two one. 0, 1, 0, 1 plus equals to the 1. 1, 1 must be equal to the 2. 1, 2 must be equal to 3. And 2 plus 3 is equal to the 5, and so on. It goes on. Okay? And so we can build the what? This structure with the what? Iteration. And so return to the self. Okay? And after that, the def next self. Okay? And so if self current and self limit, it's going here, and so the raise stop iteration just like this one, and so the result can be assigned with the what? With the self current. Okay, but what about this? Just remember the swap formulation. Self current, self next value must be assigned with the what? With the self next value, comma, self current plus self next value. And so what about this? The next value is assigned with the what? At the self current. And the self current plus next value is assigned to the another one, which means that if we sum two numbers, and so for example 1 and 2 must be equal to 3, but in the next case we will assign to this one to the self current, right? Because in the next case we will sum with the what? With the 2 plus 3. Okay? Answer. after that we need to return to the result. Okay, for example, limit 1000, and so Fibonacci gen is equal to Fibonacci generator limit. Okay, and so for new in Fibonacci gen print num can be assigned. See, one sorry, no, and this one is more useful. 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, and blah blah blah. Okay, and so if we assign the 10,000, and so see that if we assign the 100,000, and so we have this kind of numbers. Okay, this is the basic implementation of the iterable class. So we should continue with another examples by using the math class. Okay, class SQRT iterable in here, square root formulation, and so that init self, and we should give the limit just like the Fibonacci number, and so self limit is assigned to the limit. Okay, and so def iter can be masked with the what, with this one, SQRT iterator. Okay, and so we should give the what, the self limit to this one. After that, the class SQRT iterator can be defined with this one, and so that init self limits. Okay, and so self limit is assigned to the limit, and self I is equal to 0. And after that is the limits, and after that the def iter self I is equal to 0, and return self. And also def next must be used to what, to self if self I is equal to the self limit, and then raise to what, to stop iteration. Okay, and otherwise self I must be equal to the 1, and return to the what, the math SQRT value self I. Okay, so s SQRT iterable with the 2 and 5, and for f in s print f, the end of the what, to this one. See, this is the what, this is the square root of the what, up to 25 numbers in here, just like this one. 1, 2, 3, 4, 5, 6, blah blah blah, up to 25. See, we have specialized the R class based on the what, based on the this syntax. Okay, it's x5, x4. Okay. So we can build another example with the random number generation. Okay, and so class simple random def init this one. For example, we need to use the current time in here as a seed value, self seed, integer value time, time times 1000. This convert to milliseconds value. This is a microsecond. Okay, and so def generate next seed. Okay, What's the meaning of the 1 underscore? Yara, can you tell me that? Self seed is equal to self seed times 1 1 0 3 5 1 5 2 4 5 plus 1 2 3 4 5. It's a random number, but we should give the mass x 7 1 2 3 4 5 6 7. I think 2 3 4 5 6 7. Okay. Now, so what's the meaning of this 1 underscore? So see. We use a different seed just now, like this one. And so def rand int can be given with what the self low value, high value, okay? And so if low is greater than I, and so raise value error in here. Low cannot be greater than high, okay? But if this is not the case, the value is assigned with what the self generate next seed percentage value high minus low plus 1, okay? And also return value plus 1. And so we can branch the R random generation in here. But how we can do that? In the random operations or the iterable functions. And so class rand iterable is given in here, def init. And so self A, B, C, right? And so self A is equals to the A. Self B is equals to the B. Self C is equals to the C. Self simple random is equals to what? The simple or random, okay? This is the initialization function. And so def iter self count is equal to the 0. And so return self. After that, def next can be built with the self, and if self count equals to the self C, raise stop iteration, and so self count plus equal 1, and after that return self simple random rand int function with what the self A and self B. This is low and high value, okay? And so what about this L? We convert the list, and so rand iterable 10, 20, and 5, right? And so we can print the what L. If they run, we have the 5 number. If we change the last term with the 10, and so 10 random number. If we apply the 100, and so we have the 100 random number is in here, okay? Also, we can use the what the for I in the rand iterable 0, 100 with the 10 numbers, okay? And so we can print the I and end this one. And also we can give the print. See, we have the 10 number in here. And also 100 number can be generated in here, just like this one. See? Also, we can try another one. Alright, rand iterable 0, 100, and 10. Okay. Also, iter can be obtained with what? Ri iter function. This is the initial address point of this function. And so while true I is equal to iter dot next. This is the next operation here, and also we can generate the R numbers just like this one. See? Also, we should give the except. Okay? See? We can generate the 10 numbers in here. The above code and the last code is identical, guys. Okay? This iter is generated with what? It returns to the address values of this one. Okay? Return cell. And also this iter can be used with the what? With calling the next operations in here. And so this next returns to the what? To random number. See? This is useful, right? Any question? This seems like the complex, but it's not, guys. It is simple. You just need to use these functions. Okay? So in the normal case, we can generate a branch in here, just like this one. For I in R, the print I and this one. So the print I. See? 0, 1, 2, 3, 4, 5, 6, 9. Okay? But what about this? We can generate the R we create in here. And also we can obtain the R dot iter function in here. This is the same with the built-in branch function. And also try the while true. And so I is iter next. Okay? Which is created in here. And also we can print the what? This one. And what about this? Except stop iteration. Right? That's the print this one. See? These are the identical with the what? With the built-in function. This rent variable is the what? Is the basic establishment methods or the basic implementation of the built-in branch function, guys. Okay? Any question? So we can give we can write another class in here. For example, for I in reversed is a special function. We can build or give the range in here. Now show the print I and also we can print this one. So 9, 8, 7, 6, 5, blah 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 can be given in here. Okay, but how we can write this structure in our my range class? Def init should be given in here, and also start, stop, none, and step. In the default argument we have the 1, and so if step is equal to the 0, and so we need to give or the raise value error, right? And if stop is equal to the none, which means that self start is equalized with 0 and self stop is equalized with the what? With the start. Okay? And also if this is not the case, we shall give the else self start is equal to start and self stop is equal to the stop. Okay? And self step should be assigned with the step. Then iter should be returned to the what? To the self of this one. But in this case, self I should be initialized with the self start, right? and we should return to the self. After that, we have reversed function in here. We can overload this reversed function with the what? Just remember the previous examples. My range reverse iterator. Self start, self stop, and self step, right? And also that next should be given in here with the self, and so if self I is equals to the self stop and raise stop iteration, okay? Self I was equal self, in this case not a 1, this one should be given with the step, and also we should return to the what? Self I minus 1, okay? What about the reverse iterator class? My range reverse iterator, okay? So def int. In this case we need to give the start, stop, and step in here, and also self start. It's the same with the previous one. Yes, start, self stop, stop, self step, self I is equal to the stop, because this is the reverse iterator. If the normal iterator start with what? With the start, but in this case we need to start with the stop. Def iter self return self, okay? And def next should be given with the self, and so if self I is equals to 0, erase stop iteration. After that self I must be decreased right now, and also return self I, okay? For I in range 10 right now, the print I and this one, also print this one. So see, this is the normal written 0, 1, 2, 3 up to 9. But now for I in reverse my range 10, print I and this one. See, 9, 8, 7, 6, 5 is written on this page, but how can we sure this is code in here, or the overload? Reverse overload is run. See, this function right now is called instead of normal reversed function or this one, okay? Okay, any question? If there's no question, this is the last topic we have talked about in the Python. The syntax and the semantic rules are finished for this semester, guys, okay?